What's up, everybody? Today we're just going to briefly cover how, when, and why to use sets. Sets are a very important data structure. They're going to come up on a lot of problems, so it's good to be familiar with them. The general idea of a set is that a set holds unique items. The uses of that then is if you have a collection of items and you want to know how many unique items there are, you can quickly add items to the set. You can check to see whether or not something is in the set very quickly as well. And you can remove items very quickly. So, for example, if you were using a list, the process of removing from a list usually is in linear time. It runs fairly slowly. The process of adding to a list can potentially be a slow process as well. Finding out whether or not something is in a list can be a slow process. But when you use a set, typically it's using some sort of a hashing concept or a lookup. In both Python and Java, the standard set is going to be a hash set, which means you can look things up in constant time. What that means is that pretty much immediately when you try to look for something, it'll tell you whether or not it's in there. Comparatively with a list, just briefly the way this would work. If I were to have a list of words, for example, apple, banana, and kiwi. If I were to have these in a list and I were to say, okay, I want to know if kiwi is in a list, I would have to check apple to see if it's kiwi. I would have to check banana to see if it's kiwi. And I would have to check kiwi to see if it's kiwi. I have to check all the items. The way hashing works, though, which is what we're going to be focusing on with this set, is it takes the word that it's storing and it encodes this into a number. So maybe apple will turn into the number 28. Maybe banana will turn into the number 17. And kiwi will turn into the number 4. It does this by looking at the actual letters themselves of the word and coming up with some sort of a numeric value. You can imagine it like, for example, they just added the value of all the letters together. So if like A is 0 and B is 1 and C is 2, for example, if you were to add all the letters together, you'd get a number. It doesn't work like this. In reality, it's more complicated of a math function. But you don't really have to know how that works. All you need to really understand is that there's a very fast way to turn a word consistently into the same number for that word every time. And then what they do is they store that in an array. You have an array of items, index 0, 1, 2, 3, 4, 5, and kiwi, for example, would go into index 4. And then later, if you say, is kiwi in the list, then what's going to happen, or in the set, they would take the word kiwi, they would get the number 4, and they would check index 4 to see whether or not kiwi is there. And that prevents them from having to compare against every other thing that we've saved. So in the case of a set, if I've got 100,000 items and I want to know if something's in a set, I don't want to check 100,000 individual things while I'm looking for it. I want to just take the thing I'm looking for, encode it to a number, and jump right to the correct location. Likewise, to check if it's in the set, you do the same process. The word will get turned into a number, and we can check to see whether or not it's there. And to remove it, all we have to do is turn the word into a number and get rid of it. Now, all of this is going to happen under the hood. You don't need to worry about this process, but I'm just introducing this concept to give you the idea that if you were to use a vector or a list to store information and then check to see whether or not something's in there or remove it, that's going to be very slow. And when we're trying to do things with competitive programming, we need everything to happen quickly. So when we're not concerned specifically about the order, and that's the key here, we should not be concerned about the order things were added. Also, we should not allow duplicates. We cannot have any duplicates. If we added kiwi more than once, it would go to the exact same location every single time. So what I've done is I've invented a little problem here. I'm going to go ahead and read it. Very, very simple, but it's kind of mimicking a little bit the USACO style. So what we're going to do is add n items to a set. So we're going to be given some collection of n items. We're going to add them to a set and then print the contents of the set. Now, in reality, the order might or might not be the same. So you may get a slightly different output. It doesn't really matter. We just want to make sure all the numbers are present. One value per line, then remove each of m items from the set. So after adding, we're going to be removing items, printing true if the item was found in the set and false if not, 1 per line. So to kind of visualize that, I'm going to have numbers to add to the set. For example, maybe I want to have 7 items I'm going to add, and those numbers are 3, 5, 2, 3, 68, 2, and 1. When I add them to the set, I'm going to have 3, I'm going to have 5, I'm going to have 2. The second 3 will be omitted because we're not allowed to have duplicates. 68. The second 2 will be omitted because it won't allow duplicates, and 1. Once we're finished, we will have 5 items in the set, 1, 2, 3, 4, 5, which we then want to output 1 per line. So here I have 3, 5, 2, 68, and 1. Those are the numbers. After which we will have m, which represents how many items we're moving from the set. In this case, there are 3 items being removed from the set. Those items are going to be 2, 3, and 8. I want to print whether or not each item is in the set prior to removing it. So in the case of 2, I would print a true because it's in the set, then I would remove it. In the case of 3, I would print a true because it's in the set, and I would remove it. And then finally, in the case of 8, I would print a false because I don't have any falses in the set. And then finally, I want to print how many numbers remain in the set, which in this case is 3. We're also going to use a file reader, since I know most people don't like to play with those and they find them frustrating, but a lot of the problems do require file readers. So I went ahead and decided to do that as well, so we can get a little practice with file reading as well. So I'm going to run through 3 languages with this, starting with Python, and then Java, and then C++. Feel free to watch all 3 of them if you want to see a comparison for how they work. Otherwise, you can kind of approximate and skip ahead to the language of your choice. Also, all the code for this is going to be posted on REPL. There will be a link in the description if you want to just jump straight to the code and look at it on your own time. So to start out with, I have a very simple demonstration of kind of how sets work. So if I do, for example, x equals set, that's going to create a new set, and I just called it x because I was being lazy. So that is a set of items. So x now can have things added to it, and you can check to see what things are in it. So if I do x add 3, then I will have 3 in the set. And you can see that over here, I've got 3 in the set. If 3 is in X, it will print found, otherwise it would print not found. In this case, it printed found because 3 was in the set. So it's a very easy way to check to see if something has already been added to the set. If I didn't have that 3 there, or if I had X add 4, then it would just be not in the set and we would see not found. In Python, it's very easy to print a set, just like everything else. You just do print X, and then that's where that set came out here. We can iterate through for item in X print item. That's how we got the 3 here. We can print the length of the set very easily. That's where that 1 came from. And then if we do dot remove, then we can remove an item, and then you can see print X produced just set, an empty set here. So I'm going to leave that there just as kind of a cheat sheet. And then we are going to solve this prompt. So first we're going to start with the file reader. F equals open sets.in. And then the sets.in file, let's have a look here. So I've got the N on the first line, and then a list here, and then the M, and then a list here. So we're going to start by reading an N. N is going to be equal to F dot, read line, I believe. N dot read line, and then print N. We're going to have to turn that into an integer as well. I feel like there's an underscore in read line. I'll double check that in a second. Nope, there's not. Okay, great. So read line and then print N. And then for I in range 0 to N, actually, because Python, we don't have to read them individually. We'll do to add is going to be int X for X in F dot read line. Basically, what this is doing is I want to read an entire line out of the file here, which is going to be this 352.36821. I'm going to read that, and I'm going to split it by the space, which will turn it into a list of strings. Then I want to get the integer value for each value in that list of strings, and that should produce me a list of integers. I'm going to print to add to make sure that works. Incidentally, when you're writing code, I do a lot of testing and recompiling. I recommend doing the same. It's a lot easier to fix problems if you're doing lines a little bit at a time than if you write out a whole page of code. And then, if you have a dozen errors, sometimes you've got a logic error in there, or something like that, and it can be hard to track down. So I test very frequently, and I recommend doing the same. So here I've got my list of integers. Those are the integers I expected to have. So that's all good so far. So I need to create a set. Numbers is going to be equal to a set. And then for num in to add, then what we're going to do is we're going to do numbers dot add num. And we'll run that and then print numbers. So afterwards, numbers should be a set which contains all those unique values. Let me get this here. Okay, so I added the numbers, which were 3, 5, 2, 3, 6, 8, 2, and 1. And what I have here is 1, 2, 3, 6, 8, and 5. Now, I mentioned the order. This does not maintain orders. Lists maintain order. The downside for maintaining order is its extra bookwork. extra bookkeeping, and it slows the process down when you have to keep track of all the of the order. So if we can agree that we don't need the order and the order doesn't matter, and we just want to keep track of unique things, then that's going to be the easiest way to do it, is to use the set. But then, yeah, again, the order that they store in might not be the same. You notice one ended up being the first item, and that just kind of depends on the internal algorithm. Then what we're going to do is we are going to print all the numbers to a file, one per line. Let me go ahead and get my file open. Fout equals open sets.out for writing. We're going to do for num in numbers, fout.write. That number, we're going to have to convert that to a string, probably, plus a line break. That should be all the numbers there. And I'm just going to fout.close to make sure that we got that so far. All right, sets.out, and then 1, 2, 3, 6, 8, 5. And again, the order doesn't matter, so we're not going to worry about that here. Okay, so now that we've done that, we need to read an M. M is going to be int of f.readLine. And then we're going to do to remove. This is going to be, once again, int x for x in f.readLine dot split. I'm going to print the numbers that I need to remove. Print to remove. Okay, so 2, 3, and 8 are the numbers we're going to remove. So for rem in to remove, first thing we need to do actually is we need to write if it's in the file. Remember, I mentioned up here, we can check to see if something is in a set. We want to print according to the prompt true or false, depending on whether or not something's in the file. So we're going to do for every rem in remove, if rem in numbers, then we're going to do fout.write true because it was in the numbers, else, what did that tab in? Fout.write false. Okay, see if that's correct so far. Okay, sets that out, true, true, and false. Great. And then I think the final thing it wanted was the number of items that remain and the length of the set. So finally, we're going to do fout.write stir of len of numbers, and that should be 3 plus a new line. All right, so sets that out. Let's see. Oh, I forgot to remove them. That's going to be either way. Just to point this out too, we can do, let's put this here, numbers.remove rem. Let's try this again. Ooh, here, 8. Okay, so that's interesting. With the set, I hadn't double checked this, but with the set, if you try to remove something that's not in the set, it'll throw an error. I don't think it does in Java or C++. We'll have to double check that when we get there. What that means is I'm just going to have to do this only if I find it. The other thing, I guess, is you could put it in a try catch if you don't want it to throw an error and you want it to just silently succeed or silently fail. This will be the easiest way to do it, though. We'll check if rem is in numbers, then we'll write true, and we'll do numbers.remove rem. Run that again. Okay, and then sets that out. And then finally, I have 3 because there's 3 items that remain after removing 2, 3, and 8 from 1, 2, 3, 6, 8, and 5. So just as a real quick recap, and again, I'm going to leave these notes up here if you want to use that kind of as a cheat sheet. But basically, we're opening the file, we're reading n, we're reading the numbers that we need to add. Here's how we create a set. Just numbers equals set. For every number in the to add line that we pulled out of the file, we're just going to do numbers add that num. That will add it to the set. If there's anything that's a duplicate, for example, we had a pair of 3s in here, I think, and a pair of 2s as well. There was a 3 here and a 3 here, and then also a 2 here and a 2 here. If you add something to the set that's already in the set, it just silently ignores it. And then printing the numbers here, you can see I've got 1, 2, 3, 6, 8, and 5. Then for every number in the numbers, I wrote it to the string. It's, you can iterate through, even though numbers is a set, you can iterate through it the same way you would with a list. Just remember the order is not necessarily the order you put them in. I'm then reading m from the file, getting the numbers to remove. And then for every number that I need to remove, if that number is found in the numbers that I have initially added, I will write true to the file and then remove it. If it's not found, then I'll just write false to the file. Finally writing the length of the numbers and closing the file. All right, so that's the Python code. That's going to be under replit.com/@howtousecode/sets-python. So if you want to review that or use any lines from here, then that will be available for you. All right, moving on to Java. Java, I'm going to go ahead and do a sanity check here. I'm going to run this. Okay, with Java, I'm explicitly using a hash set. There is also a tree set. With a tree set, the process is very similar, except when you're searching, it uses a binary tree. I believe it's a red-black tree. I'd have to double check that. But essentially, as you add numbers to the tree, it builds this sort of hierarchy. Now, the reason we're not going to use the tree set and we're going to use the hash set is because if I were to put something into a tree set or to check to see if something's in the tree set, I have to start at the top and I have to work my way down through the tree. Now, this isn't that big of a deal. This works in log n time, which is pretty fast in most cases. But for our purposes, typically we're going to want a hash set. We're going to want to be able to look something up in constant time, add it in constant time, and remove it in constant time. There are, of course, drawbacks to this. The tree set does have advantages. For one, the tree set maintains the order. So if we needed to be able to iterate through them in alphabetical order, for example, we could use a tree set. A hash set won't allow us to do that. We would have to sort the, if we wanted to do a hash set in alphabetical order, for example, we would have to dump it down to a list and sort the list, which would be a linear time copy and then an n log n sort. So if you already know that you need to have them in alphabetical order, a tree set can be useful because then you can iterate through the keys in order. But your sacrifice then is adding and removing is a little bit slower. Most of the time, we're going to want to use hash sets for the USACO problems. In most of the situations where you would want to set, you don't need them to be in order. There has been, I think, one problem that required an ordered set, but it might have even been the Frisbee problem from this last year. But that was kind of a unique one-off, and there were multiple solutions to that didn't require an ordered set anyway. So at least at the bronze and silver level, you're not going to have to worry about anything like that. So I recommend just using hash sets. So how to create a hash set? A hash set of whatever the type is, integer or string, is equal to new hash set. We can add items with the .add function. We can check if there's something in the set with the .contains function. We can iterate through it just with a standard iterator. We can use the size function, same as we can with a list. We can remove items. That'll remove by value. So if I do remove 3, that's not like index 3. That's the value 3 that is in the list. It'll automatically box and unbox that. Just as a note, this doesn't work with lists. If you do remove 3, it would try to remove the item from index 3. If you wanted to do this with a list, I think you have to do new integer 3, something like this. And then it turns it into an object and it checks for equality. In the case of a set, because there are no indexes, if I do remove 3, it's going to automatically assume that that's an object, and it's gonna box it and then find the value of the 3. Then you can see print HS, and I have the empty set here at the bottom. So leaving that there as a cheat sheet, and we are going to read this file. So reading a file, I'm going to do import Java IO file, import Java util scanner for my reader. I'm going to import Java io.printWriter, printWriter, and I'm going to be really lazy, and I'm just going to put a throws exception here. And again, we would never do that in an academic program or in the professional world. That would be an unusual thing to do. But for our purposes, we can just say throws exception, and we don't have to worry about file handling. Okay, so we're going to start with our scanner. Scanner sc equals new scanner, new file off of sets.in. There's other ways to do this. I just really like the scanner because it's easy to work with. Int n equals sc.nextInt. For int I equals 0, I less than n, I plus plus, int val equals sc next int. And then we're going to put that into a set. So we'll make our hash set here. Hash set integer items, or what did I call it in the Python one? I want to match the variable names. We call it numbers. numbers equals new hash set integer. All right, and then we'll add the value, numbers.add val. And then afterwards, I'm just going to print numbers and we'll have a quick sanity check, make sure it's correct so far. Run. Okay, 1, 2, 3, 68, and 5. Interestingly, that was the exact same order that Python did, which suggests to me that whatever system they're using for storing is a similar mechanic. So, and that also kind of suggests that if this is a hash set and it's maintaining that order, this probably also, you know, is going to be a hash set. Just it's interesting that they're the same. Okay. So we have system of print line numbers. I got my numbers so far, so good. I wanted to print one per line, so we'll do for int I equals 0. Oh, right. For integer val in numbers, we gotta make our file writer. Print writer pw equals new print writer new file sets.out. We're gonna do pw dot print line val. And down here, I'm just gonna do pw dot close, and we'll check and see if that's working so far. Set that out. One per line, 1, 2, 3, 68, 5. Fantastic. Okay. So far, so good. Now we're going to get m. Int m equals sc.nextInt. And then for int I equals 0, well, I'm actually not going to load these into a secondary structure. In the Python, I did load these into a list because it's easy to read a line and use list comprehension. For this, I'm just going to read them one by one out of the file and process them as I go. I list them m I plus int val equals sc.nextInt. For the next item, I need to return to check if my numbers contains that value. Then I'm going to do pw.write or print line true, else pw.println false. And I'm going to do numbers.remove val. And we're going to check that afterwards. Ooh, yep, okay. System out print line numbers. Run that. And there we go, 168.5. Yep, so that's 168.5 with the 2, the 3, and the 8 removed. This came up in the Python. In Python, we're not allowed to remove something if it's not in a hash table, so I had to move it up into here, like that. Java will automatically, if it doesn't find it, we'll just ignore the statement. Python throws an error. So if we want to keep it consistent, we can put this up here, but you don't have to be as careful with it in Java. If you remove something that's not in the list, it'll just ignore it. Okay, so we're down to here. We've removed the numbers, and then we have the true, true, false. Double check true, true, false. Last thing to do is to get the size. We're going to pw.println numbers.size, and then pw.close, and we're done. Let's run that. Double check our output file. One, 2, 3, 68, 5. Yep, okay, so 1, 2, 3, 68, 5, true, true, false, and 3 items in the file. All right, so that concludes Java, and on to C++. Okay, so C++ is a little syntax heavy. Let me make this a little bigger here. With C++, we've got a set and an unordered set. Now, I've read about why the set is done with a tree set. What I had read is that at the time when they incorporated set, they were trying to finalize the tool set for C++. And at the time, the tool that they were using for sets, the best thing they had together was a red-black tree. So that's the default if you just do include set. Whereas most other languages use the hash set as the default. In retrospect, it has been commented that this may have been less than ideal and was the result of a deadline. I don't know how reliable that information is, but whatever the reason, if you do include set, you get a tree set. And as I mentioned earlier in the introduction, if you're using a tree set, your lookups and your removals are in log n time, which might put you in too high of a time complexity. Now, with C++, if you're using C++, odds are you want to really take advantage of minimizing and maximizing your time complexity. That's one of the strongest things about C++ is you have control over this. If you want to have control over this, then for the most part, in most of the USACO problems, especially at the bronze and silver level, if you're using a set, you're going to want to use an unordered set. That does make the syntax a little hard to look at. So we're going to kind of piece through this here. When we create an unordered set, we just can do unordered set nums. That's pretty straightforward. Nums.insert is pretty straightforward. That's to add an item to a set. We don't add, we insert into the set. We can output the size of how many numbers there are. That's totally fine. Iteration is a little hard to look at, but let's pick this apart. Basically, what we're saying is unordered set is the class. It is an unordered set of integers. But what we want is the iterator. Unordered set has an iterator. So we're creating an iterator called it. We're setting it equal to nums.begin, which is the beginning of the set. And then until we reach the end of the numbers, we will do this code, which is to output the item we find at the memory address of the iterator. And then afterwards, we will advance the iterator. You don't have to worry about how this works. But again, unordered set iterator, it equals numbers begin, while the iterator is not at the end, it plus plus, and that'll print out all the items. If we want to know whether or not something is contained, we have to do that thing dot find. I believe vectors work the same way. We try to find a value in the list, and what happens then is it'll generate an iterator that will stop when it finds that item. This is something you can potentially take advantage of in certain situations. If you want to actually have the iterator to the item, you then could use the find to locate the item, and then you could check to see what's the next item by progressing it. We're not going to do that in this particular project, but when you find it, it gives you an iterator to the location. But if the item is not found, then it'll reach the end. And numbers.end is indicating the end of the list. So if finding the item puts you at the end of the list, that means that the item was not found. So if it's not the end of the list, it was found. If it is the end of the list, that means you went through the whole list and didn't find it, in which case it's not found. It'll make sense if you think about that for a minute. I'm going to read it one more time. So we're going to try to find numbers. It's just a little awkward because it's like a double negative. We're going to try and find a number, and if we don't reach the end, that means we found the number in the middle somewhere, which means we found it. If we do reach the end, that means we didn't find it because we would have stopped when we found it. For removing, it's erase. So insert and erase to add and remove. This came up again in Python. In the Python version, if you try to remove something that isn't in the set, it throws an error. In the Java, it does not. Also in the C++, it does not. In the Java, I went ahead and moved the remove function up in here just so it was consistent with the Python, but you don't actually have to do that. That's going to be the same case here. If you try to erase something that's not found, it'll be totally fine. Finally, you can just do the size to get the size, and then in this case, I had a size of 0. So I'm going to comment this out, leave that there as a cheat sheet, and we're going to get this file reader and writer made. So I'm going to have to include fstream. I'm going to do ifstream fin sets.in ofstream out, and then we're going to read the first n value. So fin n for int I equals, oh, we got to get our set created. Unordered set int numbers print I equals 0 while I is less than n. Well, I is less than n, I plus plus, int val, and then we're going to fin val. There we go. Fin val, and then I want to add it to my numbers. Numbers dot insert val. Okay, so we get the numbers inserted, and then we're going to iterate through them. Okay, so we're going to do for unordered set int : iterator it equals numbers dot begin, while it is not equal to numbers dot end it plus plus. I'm going to do f out the value of iterator followed by an end line, and then down here I'm going to do f out dot close, and we'll just check real quick to make sure we have the first 5 values, not including duplicates, to make sure that's working. All right, so let's let out 1, 2, 5, 6, 8, and 3. So once again, we got the exact same order we got from the other ones. And again, the order 1236885. Let me see, sets that out. 1236885. 12. Oh, that's different. 1256883. So this one's using, it looks like a different mechanism than what the Python and the Java we're using. And again, we don't really need to know why, but it is kind of interesting. I might look that up later just for my own curiosity. Okay, so yep, iterating through and closing. And again, I stated the order doesn't matter, so we're not going to worry about the order these come in. The whole point of using a set is it's just a bag of unique things. So the order that they are put in, the order that you take them out really shouldn't matter. The whole point is that you can quickly check to see whether or not something's in the bag, and you can quickly add from the bag. Okay, next up, we have to get that m value, int m, then m for int I equals 0, while I is less than m, I plus plus. Next value, int val, then val, and then we need to check to see if the number's in there. So if, what was it? Numbers find val is not equal to numbers end, that means we found it. So we'll do faut true end line, else faut false end line. And then afterwards, we're going to remove it. Tree numbers dot erase val. Let that recompile. All right, sets dot out. All right, so we have 1256883 true, true, and false. And the last thing we want to do is input the size, which is going to be faut numbers dot size end line run. All right, sets that out. All right, so you got 1256883 true, true, false, and 3. All right, so this is a real quick recap. Setting up our file readers, reading in n, setting up the unordered set, loading n values from the file, which we are inserting into numbers. This was an iterator to go through all the numbers that are found in the set. And remember, the duplicates have been discarded. We then have m, and then for I equals 0, I less than m, I plus plus, those are the numbers we're removing. So we get the number we're going to remove. If we try to find it and it's not at the end, that means we found it in the middle somewhere, which means it is in the set. Otherwise, if we did reach the end, it's not in the set. Finally, erasing the value and then outputting the size at the end. So that's how to work with sets in each of those 3 languages. Hopefully that's helpful for you. And just again, to repeat, there should be links in the description that will take you straight to these files. And likewise, you can find any of our code on replit.com/@howtoUSACO. All right, good luck coding, and I'll talk to you next time.